We continue with the problem that we solved previously, which was c of k is equal to 3 raised to k minus 1 plus 2 raised to k plus 1 plus k, where k is greater or equal to 0. And from the previous lecture, we obtained a recurrence relation of the form, which is basically a second order recurrence relation, c of k minus 5c of k minus 1 plus 6c of k minus 2 is equal to 2k minus 7. Suppose we want to have a recurrence relation that is equal to a constant on the right hand side. So in this video, we will try to solve for a recurrence relation that has a constant on the right hand side. So to do that, we have to recall the 6 equations that we have in the previous lecture. So the first equation was c of k is equal to 3 raised to k minus 1 plus 2 raised to k plus 1 plus k. Then we have c of k minus 1, which is equal to 3 raised to k minus 2 plus 2k plus k minus 1. Then we have c of k minus 2, which is equal to 3 raised to k minus 3 plus 2 raised to k minus 1 plus k minus 2. Then we also have equation 4, which is c of k minus 3c of k minus 1 is equal to negative 2k minus 2k plus 3. So this is the first order recurrence relation. Then we have c of k minus 1 minus 3c of k minus 2 is equal to negative 2 raised to k minus 1 minus 2k plus 5. And then the second order recurrence relation, which is the answer in the reference book that we are using. So we need another equation to eliminate 2k in equation 6. So this is where we try to use c of k minus 3. That way, that would be equivalent to 3 raised to k minus 4 plus 2 raised to k minus 2 plus k minus 3. So that would be the equation, or that would be equation 7 in our solution. We need equation 7 so that we can eliminate 3 of k in the first term using equations 3 and 7 by subtracting 3 times equation 7 from equation 3. So let's proceed. That would give us c of k minus 2 minus 3c of k minus 3 is equal to 3 raised to k minus 3 plus 2 raised to k minus 1 plus k minus 2 minus the quantity, minus 3 times the quantity 3 raised to k minus 4 plus 2 raised to k minus 2 plus k minus 3. Then we move on to the next step. So what we'll do is we compute for the second half of the right hand side first. So we copy the first part, or the first set of terms, then we distribute 3. That would be negative times the quantity 3 times 3 raised to k minus 4 plus 3 times 2 raised to k minus 2 plus 3 times the quantity 3k minus 3. Then we proceed, we get 3 raised to k minus 4 plus 1 plus 3 times 2 raised to k minus 2 plus 3k times 3 times the quantity k minus 3. Then if we continue with these steps, we will get 3 raised to k minus 3 plus 3 times 2 raised to k minus 2 plus the quantity 3 times the quantity k minus 3. So we now distribute the constant 3 to the quantity k to the quantity k minus 3, so we get 3k minus 9. Then the next step, we now distribute the negative sign, so that would give us negative 3k minus 3 minus 3 times 2 raised to k minus 2 plus minus 3k plus 9. So we now rearrange the terms, so we get 3 raised to k minus 3 minus 3 raised to k minus 3 plus 2 raised to k minus 1 minus 3 times 2 raised to k minus 2 plus k minus 3k minus 2 plus 9. Then what we do is we subtract 3 raised to k minus 3 minus 3 raised to k minus 3. That will give us that equation. So we now factor out the common factor, which is 2 raised to k minus 1. That would give us the quantity 1 minus 3 times 2 raised to negative 1 plus k minus 3k minus 2 plus 9. Solving this further, that would give us 2 raised to k minus 1 over times the quantity 1 minus 3 raised to 3 over 2. So we now have 2 raised to k minus 1, 2 minus 3 over 2 times the quantity 2 minus 3 over 2. So that would give us negative 1/2. And then that would be negative 1/2 times 2 raised to k minus 1 plus k minus 3k minus 2 plus 9. Then we subtract k minus 3k. That would give us negative 2k minus 2 plus 9, and then negative 2 plus 9, that would give us 7. So we now have another equation. That would be equation equation 8. So we now have equation 8. We again eliminate the term 2 raised to k minus 1 using equations 5 and 8. So that would be 5 minus 2 times equation 8. So we write now the equation. That would be c of k minus 1 minus 3 times c of k minus 2 minus 2 times the quantity c of k minus 2 minus 3 c of k minus 3 is equal to the negative 2 raised to k minus 1 minus 2k plus 5 minus 2 times the quantity negative 1/2 times 2 raised to k minus 1 minus 2k plus 7. So we manipulate first, or we try to solve the left hand side first. We distribute 2, negative 2, that would be negative 2c of k minus 2 plus 6c of k minus 3, and then we just copy first the right hand side. Then we remove the grouping symbols again on the left hand side. That would be c of k minus 1 minus 3c of k minus 2 minus 2c c of k minus 2 plus 6c of k minus 3. Then copy the right hand side. Then we combine like terms here. That would give us c of k minus 1 minus 5c of k minus 2 plus 6c of k minus 3, and then we copy again the right hand side. So the next step is we now solve the right hand side for this equation. So that would give us negative 2 raised to k minus 1 minus 2k plus 5 minus negative 1 half, or basically we distribute 2, so that would give us that equation, or those terms, and then we solve it and we get negative 2 raised to k minus 1 minus 4k plus 14. And then we remove the grouping symbols, we distribute also the negative 1, we get those terms. And then solving this further by rearranging the terms, we remove 2 raised to k minus 1. So we are left with negative 2k plus 4k plus 5 minus 14. So 2k plus 4k is negative 2k plus 4k is 2k. Then what is left is 2k plus 5 minus 14 is 9. So we now have the terms for the right hand side. The left hand side is given as shown in the given equation. That would give us equation 9. So the next step is we now remove the k term using equations 6 and 9. How do we do that? We simply subtract 9 from, or equation 9 from equation 6. So you write the left hand side and then the right hand side of the equation, and then we proceed to solving first the left hand side of the equation, which is more complex than the right hand side. So that would be c of the quantity c of k minus 5c of k minus 1 plus c of k minus 2. Then we distribute the negative sign to negative c of k minus 1 plus 5c k minus 2 minus c of k minus 3. Then we copy the right hand side. Solving the left hand side further, that would be by removing the grouping symbols. That would give us those terms. Then we copy the right hand side terms, and then we rearrange the terms on the left hand side so that it will be clearer. So that would be those terms there, and then we copy the right hand side. Then we combine like terms, so that would be negative 5c of k minus 1 minus c of k minus 1. That would give us negative c of k minus 1, and we copy the other terms first. Then the next one is we combine 6c of k minus 2 plus 5c of k minus 2. That would give us 11c of k minus 2. So we now completely solve the left hand side of the equation. We now solve the right hand side. So we remove the grouping symbols and distribute the negative sign. So 2k minus 2k, that will give us 0. So what is left is negative 7 plus 9, or that is 2. So we now have the third order recurrence relation with a constant on the right side where k is greater than or equal to 3. That's it.